Welcome to qnawire.
Our question says that we have a 5.2 gram bullet, which I label as M sub B, moving at an initial velocity of 672 meters per second, which I write as VB sub I for the initial velocity of the bullet. And it's moving towards a wooden block at rest on a frictionless surface that weighs 700 grams. So I call this block the target, since that's the target of the bullet. So I write it as M sub T for the target of the mass of the target, and that's equal to 700 grams. The bullet emerges traveling in the same direction, but now it has a reduced speed of 428 meters per second. So I call that VB sub F for the final velocity of the bullet. For part A, it wants us to find the resulting speed of the block. And for part B, it wants to find the speed of the bullet block center of mass. Okay, so we're going to use energy and momentum conservation for this question. So according to momentum conservation for part A, the initial momentum, which is just the mass of the block times the initial velocity of the block, since the target is at rest initially, so the initial velocity of the target is 0, has to be equal to the mass of the block times the final velocity of the block, since that's its final momentum, plus, that's VB sub F, not I. Change that to an F. Plus the mass of the target times the final velocity of the target. We'll call that VT sub F. Okay? Well, if we solve this for VT sub F, this is equal to the mass of the block times the difference between the initial velocity of the block and the final velocity of the block, divided by the mass of the target. Okay, so if you plug in those values into this expression, this comes out to be 1.81 meters per second. And it would be traveling in the same direction as the bullet that's emerging out of the other side of the target. Okay, now for part B, we'll start a new page here since we ran out of room. We're going to assume that the velocity center of mass is unchanged by the collision because of momentum conservation. Since the momentum is conserved, the center of mass before and after the collision is in the same place. So we're going to do it before the collision. So the velocity center of mass is equal to the mass of the block times the initial velocity of the block, or of the, not the block, the bullet, divided by the mass of the bullet plus the mass of the target. So if you plug in the value for the mass of the bullet, the initial velocity of the bullet, and the mass of the target into this expression, this comes out to be 4.96 meters per second.